Hi everyone. So good afternoon, good evening there, and for other parts of the world, maybe it's good morning. And thank you so much for coming here today in our Blockchain 101 Foundational series. And I'm very excited to share with you a lot about blockchain on the coming weeks. And starting for the day, we will have the foundation of our blockchain presentation. So may I know how many viewers we had today? Can you comment out where you came from? So we will have some background on what parts of the world we are. Can you comment out? You can see Philippines, yeah. Okay, good. Good evening here. Yes. Okay, good. So let me introduce myself. So I will be the one who will be your partner in your blockchain journey starting today and to the coming weeks. I hope so. If you will still have time, so let's be part of this learning in this series. I'm very excited to share my insights and ideas, especially today as we start the foundations of the blockchain. And I'm Alan Young, the trainer at AR Data Tech, a technology company for the blockchain things that we need. Okay, so let me share my screen so we can start our foundation series. By the way, if you have questions and you have some things that you want to learn from, you can always message me up and we can answer your questions even though I'm still having the lectures. Okay, so Mr. Tech, can you help me out to share my screen so we can start? Okay, good. Thank you so much. So it's Blockchain 101 Foundational Series. So understanding the blockchain's role in the digital age. During these days, when we hear about blockchain, we always think about Bitcoin. Okay? We always think about cryptocurrencies or even the word scam because there's a lot of scam involved in cryptocurrencies. But what really is blockchain in today's digital age? And what does it do for us in our daily lives? So imagine if you're a farmer or a worker on a bakery or in any industries that you are in, what does blockchain's role in your daily life? So that is what we try to answer today. And I hope so that as you journey, you're learning in the blockchain, you might learn and notice that blockchain can really impact our daily lives in a very small detail in our lives, like real estate, like other industries. Blockchain can really help our daily lives. So let's start. What is blockchain, by the way? So do you guys have a bit of idea before what does blockchain means? So if you can comment out as we go through our discussion. But in the formal definition of blockchain, it is typically a ledger or a database. So a ledger means you have the informations in there, like the date that you do the transaction, like the amount of money that you send or you purchase, or even the assets that you have purchased from that time. So if you look on the ledger, you will notice that all the business transactions are inside of it. So all of those business transactions inside the blockchain is being recorded through a ledger. And that is technically what the blockchain do. So all of the blockchain will contain all the information in your business transaction. So it is simply a paper that is existing in the digital space. Okay? So unlike regular database, if you're familiar with MySQL or the SQL databases that we have in our traditional systems, the blockchain is decentralized, meaning it does not follow a certain server, or it is not just running on a single server, but it is running on different nodes. Nodes are the ones that controls or verify the data inside the blockchain. This means that every nodes or every devices manage and verify the data. So in this kind of process, you will notice that in centralized databases, there is a risk in hacking and there's a risk in altering the data. So when someone has the full control of the database, it can be easily manipulated if they got the access for it. Unlike the blockchain technology, you will have a lot of people trying to help you out to verify every transaction. So even though a single node will be hacked or get caught up, you can still rely on other nodes that are still safe and secure. So that is the advantage of the blockchain, which we will also talk more about later. But let me give you about the history of blockchain. So did you know that in 1970 to 1999, the concept of cryptographic innovations is already existing. So there are a lot of scientists and technologists and even researchers that are looking to the cryptographic innovations on how they can cryptograph every ideas and every words that they have. And in 1981, the first blockchain prototype was created. So imagine it's been a long years before we got the first blockchain. But in 2000 to 2010, this is where we materialize everything in the blockchain, where it is being used not just by paper and not just a theory, but rather a real world or a real item in the world that you can use in your daily transactions, especially in the year 2008, where Satoshi Nakamoto created or research or write about the Bitcoin white paper. So it's like a thesis that is saying that there is a cryptocurrency that can be run by blockchain that can allow people to transact using cryptocurrencies or particularly the Bitcoin of Satoshi. And in 2009, that is finally the time the Bitcoin was introduced and launched. So that is the first time a Bitcoin was created where it is called the Genesis block. And we will talk more about that as we have the demo in our blockchain later on. But in 2010, this is what really revolutionized every blockchain transactions because Ethereum white paper was created. So Ethereum, when Ethereum goes into the marketplace, into the world of cryptocurrencies, there is a concept that exists that in really enhance the security and the capability of blockchain technology, which is called the smart contracts, which I will explain more deeper later. But technically speaking, smart contracts are just contracts that execute the rules, even though some people will not agree. So, unlike the contracts that we have that can be breached and can be altered, smart contracts will always execute no matter what happens in the transaction as long as the rules are being followed. And in 2015, Ethereum blockchain was finally launched. And we know that Ethereum is one of the famous cryptocurrencies that we have in the market today. And the present time, 2016, there is an introduction of private blockchains. This is the time where the integration of blockchains are introduced to certain companies and being used by some institutions to enhance their capability in the digital world. And in 2018, we got the NFTs. Okay? So this is another economy that boomed out when cryptocurrency was introduced, but we will talk about it more later. And 2022, the evolution of blockchain for greater scalability, efficiency, and connectivity was created and being developed until this moment, right? So that is the overview of how was blockchain improved from the past years. So right now, in the blockchain, there is a strength that you can found inside its process. And this is called the distributed ledger technology. So, in other words, as I said earlier, a lot of users called nodes has an access on the multiple datas that each blockchain has. And you will realize it later more when I show you the demo on the last part of our session. So each nodes can verify each data simply because all of the information are being transmitted to each other. It's like a chain. That is why it's blockchain, because it's a chain on every blocks. And everyone has a lot of access on every blocks that we have. So it is like a public billboard where people can see all that is happening within an organization or every transaction. All right. So that is why it's very difficult for cyber attacks. So if you got a question, it's most probably why does blockchain matters in our daily life? Well, number one is what we call transparency. As I said earlier, unlike traditional systems, it is very easy for the blockchain to distribute your information to the public. So you will have transparency on every transactions that you have. But let me clarify that even though your data is being transmitted to different nodes or different devices that verifies your data is still safe and your privacy is still on good track because developers can do ways on how to enhance and to filter out the informations that they will share to the nodes, especially your personal informations are still safe in the blockchain system. So what we have here for the transparency is good for institutions like government organizations because you will see how the funds of the public are being spent easily. And you can also use this for the private corporations to avoid theft, fraud, and a lot of things that can happen in a company. Okay? So if you have questions again, you can comment it down. And another thing why does blockchain matters is because it improves security and blockchain achieves security through cryptographic hashing. So what is cryptographic hashing? It is a blueprint that you can see on every words that you put inside the block. For example, my name, when you put it in the block, there's an equivalent cryptographic hashing that can evaluate its data. And the same formula or the same security or the same tool that we are using when we are chaining the blocks together, which we will see in the demo on the later part. So everything that you pass in the blockchain has the records of the previous blocks in the form of cryptographic hashing. So this kind of process enhances security and cannot be altered easily when being attacked by cyber attackers. So another thing is the decentralization. We all grow up that all of the systems, all of the institution are mostly centralized. This is just the time in the whole history of the universe that decentralization has become a big word for a lot of industries because people are starting to realize that centralized system and centralized organizations are often controlled by few people. Unlike decentralization, people can have a part on the security, verification, and even they have the power to see everything inside what's happening on a system that is in the blockchain paradigm. So traditional banks, companies are shifting gradually from centralized to decentralized process. However, there's still a lot of challenges that we are facing, and we know that a lot of restrictions are into cryptocurrencies right now, and we are looking forward that our governments and our authorizing bodies will finally regulate on how we can use cryptocurrency or blockchain because decentralization is really a strong point when it comes to transparency, security, and verifications of data. Another thing that makes blockchain stand out from any form of web process is consensus mechanism. Consensus mechanism means before you can add another transaction to the system of the blockchain, there there are a lot of people that needs to approve everything. So before you can, for example, if you have a new transaction like withdrawing your money in the bank, and withdrawing a money in the bank will create a new record in the ledger of the blockchain. And when you created that kind of ledger, there is a consensus mechanism, or there must be a voting agreement to each of the nodes or the people verifying the information before the transaction can be can be succeed. So they need some verification from this kind of system. And right now there are two famous process of consensus mechanism. This is what we call the proof of work and the proof of stake. So what is the difference between the proof of work and the proof of stake? Let's have a small overview on what they are. So the first one is the proof of work. When we say proof of work, this is the time miners compete to solve a mathematical puzzle. So you might be asking or wondering, how does or what does mathematical puzzle do in our Bitcoin or blockchain transaction? So the short answer is in proof of work, because miners try to solve or try to verify everything of the in the transaction, in the multiple transaction of blocks. Mathematical puzzle are there to have a delay in their process, so that in the proof of work system, because they are competing to solve the mathematical puzzle, the one who solved the mathematical puzzle will be the one to earn the right to add a new block to the transaction. It means in a circle of blocks or nodes that will verify the data, the one who solves the mathematical puzzle will have the right to verify first if all of the transactions that being added to the ledger is good. So what do they get if they try to solve the mathematical puzzle and verify the transactions? The short answer is they will get a reward. It's a form of token or even cryptocurrency. That is the purpose of proof of work. Okay. Now, in the proof of stake, it's a very different approach. Why? Because the proof of work has this advantage. Because miners compete to each other, their computers or their servers or systems are consuming a lot of energy, and it's not good for the environment. Imagine a lot or thousands of supercomputers trying to solve mathematical puzzle will consume, let's say, I think it's on, according to the research, it's more than the electricity being used by Sweden. So it's very unethical to our nature. So that's why another form of consensus mechanism was created, which is called the proof of stake. The difference between the proof of stake and the proof of work is in the proof of stake, the nodes will deposit, okay, cryptocurrency. So this will enable them to have the rights to verify the transaction. So in proof of stake, instead of solving the mathematical puzzle, they will be chosen randomly based from the stake or the deposits that they have made. So if you will ask, why does they need to deposit in the proof of stake? It is to ensure that they will do their job on verifying the data. That once they verify a data, when they were randomly chosen by the blockchain system, and they verify the data, this will ensure that they will do their job. So in case they will not do their job, what will happen is the deposit that that they have put on the blockchain system will be will be get from will be get by the system. So they will have a penalty on doing those wrongdoings in the verification process. So that is the difference between the two. Although right now there are a lot more developments being done for consensus mechanism, just like proof of history, which is another topic in the future, I guess. So there's a lot of things that being improved in the blockchain world. So if you have questions about consensus mechanism or the previous ones that we have discussed, so you can always ask. So let's have the part on we study and analyze how does the blockchain works. Okay. So first thing that we need to see, as we can see in my slide, there is a structure of the block. So this is what we call the ledger. Okay. So it's like the paper that we record everything up. So what can we found or what can we look for inside a block? So number one is the index. That is the number of block, which indicates what is its order in the blockchain system. So the first block is what we call the block zero or the Genesis block. So as I mentioned before, just like the Bitcoin, so it has a Genesis block where the transaction has started. And another thing is we have the timestamp. Timestamp is very important to let us know that that is the date and time that that the transaction was made or created. We also have the previous hash. This is a reference of the previous transactions before the transaction inside that block. So for example, the current block is about withdrawing my money in the bank. It should ensure that the previous block was also connected in this current block because the previous block will tell how much is the money that he can withdraw. Let's say, for example, I withdraw $50 or 50 bucks in my bank, and on the previous block, it only says that you only have 20 bucks. So therefore, the system will reject your transaction. And I really wish I have 50 bucks. So that's one of the things that blockchain is doing in our structure. So we also have a hash. This is the one that you will pass on the next block. In other words, this is the ID or the transaction ID of your block. Each block has its own hash. Okay? And of course, the data. This is what you did in the transaction. So it is very flexible. That's why any industries can be implemented in the blockchain. So for example, if this is a finance application, it's about withdrawing, sending money, purchasing online items, etc. Okay? Now, we have the hashing and cryptography. As I said earlier, the hash is just a blueprint of what's inside the data. So what's inside the data can represent the hash inside our block. But of course, additional security was created, and we will see that when we got into the demo part. So every block was linked to the next block. It has the data of the previous block, and it has the data that will pass on to the next block. So, for example, by example earlier, if I got 50 bucks here and you try to withdraw 75 bucks in this block, it will be rejected because according to the previous block, you only have 50 bucks. So that's how the logic of cryptography works. Okay? Now, of course, the logic is to chain the blocks together. So this is just a simple example, but in reality, thousands of blocks can even verify our data, which we will see later in the demo part. So let us have a short overview on what's really happening inside every mining and validation of data. So the first thing we will have is we will have a new transaction. So for example, let's say we are in the industry of e-commerce. So in my example, let's say I purchase a new refrigerator in my kitchen for my kitchen. So when I purchase the refrigerator, so the refrigerator's price is $200, let's say, or it's too expensive. I think it's $100. Say just a small refrigerator. So the first transaction will be broadcast to all nodes. Okay? So let's say we are using the proof of work consensus mechanism. So in the proof of work, so that part that we have broadcast to all nodes will be verified by every nodes by solving first the mathematical puzzle. So the one who solves the mathematical puzzle will the first to verify the transaction. So, for example, this node A has solved the mathematical puzzle, so he has the right to verify the transaction. So when he tries to verify the transaction, he will collect the information. He will see first that I have the money to buy the refrigerator in my account. So once verified, all the transactions will be created into a new block. Now, that new block that was created by one node, by that particular node, it will be hard to, let's say, this kind of node will have on the queue of all the blocks that needs to verify. So it will be broadcasted to other nodes. Okay? So those other nodes will try to verify the one or that block that the first node has verified. So once they validate, let's say there is 100 nodes that will verify that particular block. Let's say there is 100 nodes. That 100 nodes will accept it if they see that everything is correct or there are no bad data inside the transaction. So when they try to accept the transaction by all nodes, what will happen is they will express their acceptance by creating the next block in the whole blockchain. As I said earlier, it is a duplicate to each node. The ledger is being duplicated. So they will also create that block. They will copy that block from the first one that created the block, and it will be copied for the whole blockchain, which will have the uniformity inside our blockchain system. So that is how mining and validation works. Okay. By the way, I'm reading some comments. So others are came from South Korea. Yes. So let's continue. So types of blockchain. So do you know that we have a lot of blockchain existing? And the first one is what we call the public blockchain. So a public blockchain can be participated by everyone. It means it doesn't matter what country you came from. So it's completely decentralized and can be participated by other people. So the examples of it are like the cryptocurrencies that we have, Bitcoin, Ethereum. That's why you can buy Bitcoin in your country or buy Ethereum and sell it. So it's very easy because everyone is being involved. However, the next one, there is what we call the private blockchain. So why does private blockchain was created? Simply because private organization, of course, need to control their data. So they want their data to be just internally available to their people. So that's why a private blockchain was created. It is a blockchain, but the information can only be participated by those participants within their organization. So that is the difference from the public blockchain. And of course, the cons is it is less decentralized, okay? And it relies on trust on a central organization. So somehow it is still a semi-centralized system. But that is one of the types of blockchain that suits their organization. Okay. And we also have what we call the federated blockchain. So it is semi-decentralized and it is controlled by a group of organization rather than a single entity. Unlike the previous blockchain, the private blockchain that is controlled by one company, let's say, the federated blockchain was controlled by multiple company or multiple organizations. So, for example, 5 organizations will divide the powers on the verification and mining on them. So this created the federated blockchain. So partially it is still decentralized because you still involve a lot of people to verify everything up. And also it promotes collaboration among trusted parties. It is not as open as the public blockchain. However, the people who will verify the information will be trusted. Although the cons is it has a limited transparency. So it is still under a semi-centralized process. Okay. And we also have what we call the hybrid blockchain, which we combine the private and the public. So it means that in a certain system, for example, there are parts that are available to the public and there are parts that are not available to the public, which is only available within their organization. So it is their own will to choose on what they will share to the public and what they will share just internally within their organization. So the pros of it is it offers privacy and flexibility. So they know what to give to the people, they know what to hide the confidential ones. However, the cons is it requires careful design and maintenance. So developers and designers of the blockchain should ensure that the system that they will create really protects the confidential data and really gives to the people the data that should they distribute. So that is the pros and cons of the hybrid blockchain. Okay. So any questions so far from the audience we have before we go into the next topic? So if you just have questions here, you can comment down below and we will try to answer. And I also have some other team members here who are also watching. So if you got some problems or questions also, so they can ask. Is there an example of blockchain technology developed by Filipinos? Upon from my research, I haven't seen yet. What I heard before is there is a cryptocurrency developed by a Filipino, but there's a lot of people who say that it is just a scam. So I'm not really familiar if it's really true or not because I didn't experience that one. I don't want to mention the name of that celebrity, but yeah, there is an issue before about that. So I hope that answers your question. I'm not really sure if there's a blockchain in the market really developed right now by a Filipino. But if there's not, and we hope that someday we will have, because we know that having a own cryptocurrency, I believe that it will boost the economy because cryptocurrencies created a lot of new economies which we will tackled on. Okay? So let's go back to the discussion. Where to use blockchain? So there's a lot of people that is asking, what is blockchain for me, or what does it do to our technology or our daily lives? Does it matter? Does it really help governments or organization or economy? So those are the questions that we will have. So right now, what we know is number one, cryptocurrency is the one that was created because of blockchain technology. And one example of that is Bitcoin, which is a digital gold or store value. By the way, I'm inviting you next week. We will have a more in-depth discussion about Bitcoin. So this is a topic where we deep down or we study more about the details on how Bitcoin was created and its purpose and the legacy that it had to the cryptocurrency world. Okay? So Bitcoin currently is called the digital gold because it is only 21 million in quantity. So it's very scarce when it comes to the resource. And next is Ethereum. So this is the platform for decentralization and smart contracts. And because of Ethereum, let's be very thankful to Ethereum that blockchain technology can be used in our web systems and mobile applications. Okay? And smart contracts. Now, what does smart contracts really mean? So imagine a normal contract between us. Physical contracts can be breached and other parties can turn down the contracts. So smart contracts is something that when you deploy, the system will do what you have told or will immediately follow the rules that you have set in the smart contracts even though the third party don't agree to the transaction. So you will be ensured that by having smart contracts, what you have been agreed before will be go into execution. So that is the purpose of smart contracts in the blockchain world. That is why a lot of companies are transitioning to technology such as the blockchain because of smart contract. Okay? And in supply chain management, for example, so if you have a company of inventory stocks or raw materials like that. So those kind of business and industries can really have the power of blockchain in their process because it increase the transparency and reduce fraud. As I mentioned earlier, every data is being verified by thousands of nodes. Okay? So voting systems. Did you know that voting systems can be very easy and very efficient and reliable when you apply blockchain technology? Because people will now have the trust that their votes are really counted and their votes are not being altered or being changed. So it will increase the trust in government organization. And public opinion will also be in the side of trust for our authorities because blockchain will enable them to see every data that is coming to the voting systems. And also, private records. So, blockchain technology will ensure the privacy. So, when you apply the, let's say, private blockchain or the uh, hybrid blockchain to a private records, you will really have the balance of the data that you will secure and the data that you will share to the customers or your people within your organization. Okay? So those are the industries that we can use blockchain. And we will have another sessions about that where we can use blockchain even in real estate. Did you know that? We can even use blockchain in real estate. We can use blockchain in social media and everything. Almost everything in the internet can be applied with blockchain technology. Okay? And of course, blockchain is not perfect, just like any of us. So blockchain needs a lot of improvements still. Number one is scalability. So there are blockchain systems right now that struggling because of course, as I said earlier, there are thousands of nodes that verifies information. Therefore, it can cause traffic on the verification process, especially on the proof of work consensus mechanism. Okay? So one of the solutions they're trying to develop is the layer 2 protocols. So it is like a other bridge that will transmit the data inside the blockchain. So just imagine like in expressway in our physical roads. So instead of just going to the national roads, we have expressway, we have skyway. So that's the analogy of the layer 2 protocols. Okay? And we also have the energy consumption. So especially in the proof of work, as I said earlier, there are thousands of nodes consuming a lot of electricity. So it's not good in the environment. However, there are a lot of efforts being done right now to use some alternative energy source like sun energy or the solar energy and some windmills and any other alternative energy. And interoperability between different blockchain. So right now, different blockchain often has a difficulty communicating each other. So unlike the traditional web applications, there are a lot of APIs that is being shared to different system. But right now, different blockchain still has a lot of improvement needed to solve those issues. Although some systems are already being developed, just like the Cosmos. So those are the tools that are currently in the marketplace or in the market that we can use for this kind of problems. And of course, regulatory concerns. So we have a lot of countries that are still not or they are still not into cryptocurrencies. So they don't trust cryptocurrency yet, or they don't believe in cryptocurrency. And even a lot of my relatives, in my personal experience, even though I'm promoting blockchain and cryptocurrency, they still not trust me out enough because they don't trust digital assets and digital technology. They don't trust it well. So we have regulatory concerns, especially not just in our family, but in the government, in the national level, because a lot of government don't have the rules or the laws for cryptocurrency yet. So very few laws are created and to regulate our blockchain technology and cryptocurrency technology. So if there's an issue, so of course there are plans for development. So the rise of decentralized finance. So we will have in the future, I'm imagining we will have a lot of banks that are decentralized instead of our traditional banks. And this is good thing for me because it will lessen the transaction fees because we will not depend on third party institutions. So for example, you will have a money inside a bank and you need to send it to other banks. You don't need a third party that will send it to them. It can be sent directly because of the decentralized system. And of course, we have ongoing research and development. So as I said earlier, there is a plan to improve consensus mechanism, just like the proof of history, and it also enhancing security features and quantum resistant cryptography. Means that the technology of cryptography or hashing the security of our blockchain, it will be more resistant to attacks. Okay, so potential impact on various industries. So in the area of finance, we can have a cheaper transaction internationally. So as I said earlier, because we will strip out the third party system. And we also have in real estate, it will make easier process for property transfer and title management. We all know that it's really complicated to transfer a title or a property. It involves a lot of things, documents, etc. But blockchain can help and help us reduce the process and verify it easily. And of course, in government, blockchain can increase their transparency and efficiency to the public service. Okay? So, in conclusion, before we have the demo, so blockchain is not yet perfect. Okay? And you cannot deny the fact that it revolutionized the way data is being managed. Okay? There is no technology before that will enable you to be verified by thousands of nodes or people. And there's no technology before to make the system decentralized. So thanks to the blockchain, where it did the technology for us. Okay? So in a very statement that I have, the servers controlled by big tech giants are now gradually being replaced by blockchain, which is more people oriented. And I hope uh, those companies will not get mad on me, but that's the reality that I'm seeing in the future, I think. And I think even them will adapt to the blockchain technology, which will transform and really revolutionize the way the system is being created in the digital space, because it will be more people oriented rather than eccentric or centralized systems being controlled by small group of people. Okay? So any questions before we go into the demo? You can comment down below and we can answer it. And by the way, this is the list of the readings that you can have. So you can screenshot these readings. So if you try to have time and have some read, so it can help you really to understand those blockchain basics and foundation. Okay. So I think there's no question. So let's proceed to the demo. So we can visualize what we can see in the blockchain. Okay. So we can enhance our view on the blockchain. Okay, good. Thank you. So the first thing we can see here is what we call the hash and the data. So every transaction has a data. So for example, you withdraw money in the bank or you sell something, you buy something from the internet or even physical store, it involves a data. So every data has an equivalent hash. This is one of the technology that really improves the security of our system and even make it more reliable. Let's say I put my name here. Okay, you will see that a whole Nobel. This hash will have the equivalent, or sorry, that this data will have the equivalent hash even you put uh, whole whole rules of your government here, you will have the equivalent hash. And how this technology? So this is how it works. When we go to the blockchain, let's click the blockchain, and let's see blockchain transaction. And let's just wait for it while it's loading. So it's a bit slow because this includes mining and other on your own computer or PC. So you can also try. Okay, so here's an example of the block. As I mentioned earlier in the structure of it, we have the index number, block number one, okay, and we have the nouns. What is the nouns? This is the mathematical problem that we need to answer. So this kind of example uses proof of work consensus mechanism. So these nouns is related to the mathematical formula that a miner should answer or should solve. Okay? And in the hash one, okay, we can see that there's a hash in it, but it starts with four zeros. Okay? What does this 40 means? It means that this block is signed or it's validated. So when a hash is signed and validated, it means it's part of the blockchain. It was accepted by the blockchain. Okay? So when you try to alter the data inside the block, what you will see is it will turn red because the hash was changed, because you changed the data. And we need to verify the new data that was created by adding the four zeros here. So how do we add the four zeros here? By solving the mathematical formula. So what is the mathematical formula in this part? We need to find the perfect combination of nouns to have the zeros align again. To have the four zeros align in our hash. Okay? So for example, you put number 0, you have number 2 in the first digit of the hash. It's not the right number that we are looking. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. So it's hard to find the right digits to have the 0 in our lineup. So technically speaking, that is what mining will do for us. To find the right nonce that equivalent for the signing of the hash. So when you click mine, and you need to wait a little bit more because mining takes a process. Okay? So it's one of the when you try to mine or solve a it will have a little bit of will solve it one by one. So in this example, okay, the mine value of nonce is 151524. This enables to have the four zeros inside the hash. It means that the hash was verified. Okay? So that is the process. But that is just a single block. What if we have the blockchain? So when we go to the blockchain demo, this is a collection of the block. This is ledger number one, ledger number two, ledger number three, four, and five. So we have five ledgers here. So when we try to change one of the data, let's say change number four, it will turn red because you edit the data and it also altered the hash. And not just that, the next block, block number five that relies on the previous block, you will see that you will have the previous here is also errored out because you have altered the previous block that is inside of it. Okay? So the other blocks here didn't get affected because they are the previous blocks. But the block number four, because block number five relies from this block, okay, because of the previous hash, it was affected by the modification or the alteration of the data. So what does the miner do in this kind of process? So they will mine this out, okay, to verify the transaction. If this is right, okay, they will mine it and they will find again the proper nonce value. And again, it will few moments and few time because it's solving the mathematical equation. There we go. So we got the right nonce that solve the mathematical equation that give it the right hash. Okay. However, the next block is still in red. It means the block is not mined easily. Okay. You need also to mine this block so the data will be aligned. So when we mine it, it's mine. The more previous block you altered or edit, the more you need to mine everything. That's how hard it is. For example, when I edit this one, you need to mine number two, you need to mine number three, four, and five. Okay? Before you can make the data correct. So if but maybe you could ask the question, if we can alter the data and just mine it, how does blockchain secure our data? So that will be a good question. That is why the blockchain is distributed. Okay? When we go to the distributed, okay, let's just see the visualization. Okay? The blocks are distributed. In peer A, we have block A to 5. And when we scroll down, we have another peer, which is a complete copy of this ledger. So imagine this is node number one, okay? Because as I said earlier, blockchain is a collection of nodes that verify the data or the ledger. So we have peer A, peer B, and peer C. So these three are copied by each other. So if you try to mine this block and mine this block, you might get the correct combination of the mathematical problem, but you will not have the same hash just like what we have in peer B and peer C. And they will reject the transaction made in peer A. You're seeing the logic? So they will be the peer B and the peer C will verify the data in peer A, and when they see that they don't have the same hash anymore and it's being altered or been modified, they will reject the transaction. So even a hacker hacks peer A, peer B, and peer C will verify the data. So that's how secure blockchain is. And remember, it's not just three persons or three nodes. It's a thousands of nodes that verifies the transaction. Okay? And what about tokens? So let's go to the tokens, a more complex example. Tokens is the real example in the real world. So let's say, for example, Darcy wants to give Bingley a $25, and Elizabeth wants to give Jane $4.27. So in each block, it will have, let's say, 5 transactions, and those 5 transactions will have an equivalent hash and a previous hash. So even though how many transactions you have, like this or this, you will always get a hash. Okay, no matter how many transactions the block contains. And the same logic goes when you try to alter this data, peer A, okay, for example, you alter the data in peer A, peer B and peer C has the complete copy of its transactions. Okay? That is why even though you alter peer A, peer B and peer C will really see if all of the transactions in each block are related to each other or they are same with each other. And if they detect that it's not, let's say for example you edit this part, okay? Let's say it's peer A. You edit this part and this part is not the same with the block 5 in peer A. So peer B will automatically reject it. And having a rejection inside the blockchain will cause the transaction to fail and it will not proceed because that is their purpose, okay, to verify everything out. Okay. So what is Coinbase? So why do we have a Coinbase not just focus on the token that records transaction? Well, Coinbase is very important because let's go to Coinbase. Let's say Anders will give Sophia $10 and Anders will give Lucas $20. So what is your way to know if Anders really have $100? So Coinbase is the key that do the stuff. Okay? So that's how it really secures our data. So in our Genesis block, you will see that Anders deposited $100 in his wallet, e-wallet, and then later parts he will give money to other people, and the block will know or the nodes will know that he has that amount of money because it is registered in his Coinbase. And each block will have the copy of his Coinbase. Okay? So that is the purpose of having a Coinbase. That is why you will see a lot of wallets in a blockchain system. Okay? And remember, it is distributed. So peer A is also in peer B and it's also in peer number C. And again, altering one of the data inside of this block will cause a transaction to fail because they will reject it as long as a node see that there is a modification of the data. So you in other words, you are having a lot of systems or a lot of thousands of servers verifying your transaction. You're relying on different nodes or different servers rather just relying on a single server. So that is how strong blockchain is in our systems. Okay? So now that I have demo blockchain and the coin in our lecture and our examples here. So I want to know if you got questions on the blockchain and what you have learned so far. So let's have the Q&A before we end our session for today. So if you have questions, you can ask me out or any clarifications or if you have a lot of things that you want to share, what you have learned so far. And by the way, I invite you to the next series. On the whole November, we will have this Blockchain 101. So this following series will enhance your knowledge in the blockchain system. Okay? So some questions. I'm entertaining questions right now. None so far. Okay. All right. So if you don't have questions anymore, so thank you so much for joining our session for today. And I'm very grateful on your precious time spending on this webinar. And I hope to see you again on our next series. especially next week, which we will talk about more about the Bitcoin and what in the system and the history on how it was created and developed by Satoshi Nakamoto. So have a good day, everyone, and thank you so much for joining up. Thank you. Bye.